Okay, I'm just going to remind you how to label the sides of a triangle. So we have the angles in the corners. We always use capital letters for those. So we've got capital A, capital B, and capital C. And here is angle A. And the length of the side, which is opposite to angle A, we use a small a for that length. And the same thing for angle B. The side which is opposite to that is small length b, and opposite to angle C is length small c. Okay, now what we're going to do now is we're going to just show you the formula for the area of a triangle. So obviously the normal formula for the area of a triangle is half base times height, or base times the height divided by 2. So in our triangle here, obviously normally we just know some of the lengths and some of the angles. We don't know the height, but we can use trigonometry to find that out. So let's have a look what we can do. Now what I'm going to do is I'm going to use this triangle on the left. So I'm going to use angle A, and here you can see I've dropped a perpendicular down, and this is the height of the triangle. And we can see that we've got a right angle triangle, and we know the opposite and we know the hypotenuse. So the relationship between the angle, the height, and this length b is actually sine, isn't it? Opposite over hypotenuse. So what I can say is that sine of A, which is opposite divided by hypotenuse, is actually in our diagram is h over b. Now if I rearrange this, I can take the b to the other side and multiply. I've got b sine A equals h. Okay, so what I can do now is take this formula for the area of the triangle, and now the base length is on this big triangle is actually c, so that is the base. The height of this big triangle I've just shown is b sine A, so I can put b sine A here instead of h and divide by 2. Okay, so this gives us the formula that we can use to find the area of a triangle. Let's just tidy it up a bit, because normally in the formula booklet you don't have it written like this. It's actually written, instead of divide by 2, we put a half at the front, and c times b, well, it's easier to write it as bc and sine A. So this is the formula that's in the IGCSE formula booklet. Now we can swap all these letters around. Actually, you can have a version, for instance, another version is half AB sine C. That's equivalent, yeah, just using a different angle. But it's better just to remember one, and to remember that the way it works is basically you have an angle. So if you imagine we were finding this angle here, we had the angle A and the two sides next to that angle, then that's how it works. So you don't really need to remember which letter goes where. Just remember you need an angle and the lengths either side of that angle. So let's do an example. So here's a couple of examples. So let's call this number 1. Okay, so you can see we do have this situation where we have an angle and two sides either side of that. So you've got two sides and the angle in between, and that's always the situation you need to use this formula. So let's have a look. So all it's going to be is a half. B and C are the lengths either side of that angle, so it doesn't really matter which way round you have those, doesn't matter. So it's going to be 10 times 8 and then sine of 30. Okay, so then we could just go onto our calculator, or actually in this case, hopefully you remember that sine of 30, it was one of the ones that you had to remember. Do you remember? Well, yeah, sine of 30 is half, isn't it? So what we've got is, well, it's basically 10 times 8, that's 80. 80 times a half, that's 40. Times another half, that's 20. So this area is 20. And if the lengths were in centimetres, it will be 20 centimetres squared. Okay, let's have a look at the one on the bottom. So again, we have the correct situation where we have an angle and the lengths either side of that angle. So this is always the case we need. So all we do is just use the formula. So half 9 times 12 sine 42. Okay, so let's just work that out. Okay, make sure the calculator is set for degrees, obviously. Okay, so it's 36.1 centimeters squared if it was in centimeters. Okay, one last question. Okay, it says the area of this triangle is 17 centimeters squared. Find the value of x. So this is kind of like a reverse question. So let's use the formula again. Okay, so we don't need to worry which letter is which necessarily, because we know we've got an angle and two sides either side. So substitute what we know into this formula. We know the answer for the area is actually 17. B, well, let's call that, let's use the B as 7, shall we? And the C is x, doesn't matter which way around these two are. And then sine 75. So I think you can see where this is going. We've got to rearrange this equation. Now, probably the best thing to do is to times by 2 first, and that'll be 34. And we've got 7 times x, so 7x sine 75. And we want just the x, obviously, so we need to take the divide by 7 and also divide by sine 75. You can do that all in one calculation, because you just take both down onto the bottom. So then we just work that out. Now, when you do that, just be a little bit careful. So we have 34 divided by, you need to put a bracket around the bottom, because otherwise it'll divide by 7 and then times the whole of that answer by sine 75, whereas actually you want the sine 75 on the bottom. So it's better to do it like this. 7 sine 75. Okay, so we get 5.03 for x.